Hey everyone, today we are solving LeetCode problem number 1287. Element appearing more than 25% in the sorted array. Okay, in this problem we are given an integer array which is sorted in non-decreasing order, and there is exactly one integer in that array that occurs more than 25% of that times. So let's say our array size is n, so there would be any element a which is more than 25%, which is more than n by 4 times in this array. So how we are going to solve that? The first thing is in our mind comes like why don't we capture the frequencies of all the elements in the array and match that frequency of every element with n by 4. Whether the frequency is n by 4, so that is going to be our candidate answer. And to capture the frequency, what do we use? We use hash map. We do the hashing to capture the frequency. But this technique is not going to be optimal because it is using extra space, and we don't need that because the element is sorted. Okay, so this hash map is not utilizing the property that the element in the array are sorted. So second thing can be capturing frequency while iterating through this array. Because the elements are sorted 1, 2, 2, 5, this array is sorted, and if we have to check for 5, all the 5s will be together, and all the 2 will be together, all the 1 will be together. So we can directly calculate the frequency while iterating over this array. Okay, so let's take this example. Over this example, we can just directly calculate the frequencies of each element. So let's say for the first element, for 1 count is 1, the current element is 1. So we'll move our pointer to 2. Now 2 is not same as 1, so our count will be reset to 1 and the current element will be 2. Now at third index, the count will be updated to 2, and now at the next index, that is not equal to previous one, so our count will be reset to 1, current element is 6. At the next point, count will be updated to 2. Now count will be updated to 3. Now count will be updated to 4. Okay, so this is our count so far at till this index. So while iterating through this and capturing the count, we can also compare our count with value n by 4. N is the length of this array, which is 3339. 9 by 4, 2 point something. After that, like at this moment, we have captured the count which is 4, or maybe even at this moment count is 3 or 4. We have found that count is greater than n by 4. It means that is our answer. The 6 is our answer. In this way, we are not utilizing any space like hash map. We are just iterating over it and capturing the frequency. So even in the hash map case, the time complexity is O of n and the space complexity is O of n. But in this case, the time complexity would be O of n, but space complexity will be constant. So we are not utilizing any space. So this is a better solution because our input array is sorted. But we can further improve that. Let's take this example again. I have taken a simple example with 8 number of elements. Let's say 2, 2, 2, 2. So if an element is more than n by 4 times, so why don't we just break it into 4 sections? If we have broken into 4 sections, so the element must be from these 4 sections, and if it is more than n by 4 times, so that is going to be at this meeting point for sure. So if that a element belongs to our first section, it means that is going to be at this point for sure. Let's say if a is from second section, So that might be overlapping with this point or maybe this point. If our A is from third section, so that is going to be overlapping with this section or this section. If A is filled in fourth section, let's say our whole fourth section is filled with A, so that is definitely going to be overlapping with this point. So we can see that if an element is appearing more than n by 4 times, so that is definitely going to be at these positions. What are these positions? The first one is n by 4, second one is 2n by 4, third one is 3n by 4, because this is n and this is 0. From 0 to n, the n by 4th element, 2n by 4th element, 3n by 4th element, these three elements will be the candidate to our answer. And in the problem statement, we are given that there is exactly one integer in the array that occurs more than 25% of the times. So if there is definitely an answer, so these three will be the candidate to our answer. So you can further solve that. 2n by 4, n by 2, 3n by 4. Also, the given array is sorted and we have three elements. So for each element, can we find the first occurrence and the last occurrence in this array? Yeah, definitely. And how do we do that? We can do that using binary search. Because it is a sorted array, so we can find the first element, first occurrence and the last occurrence in this sorted array. So for each element, if we have found the first and the last occurrence, we can find the segment length. How do we find that? The last occurrence index minus first occurrence index plus 1. So this is the segment where n by 4 element is present. Let's say it is A, B, C. So we have three element A, B, C. This is the segment for A element. So we will capture the length for A, B and C. And from these three elements, there will be one element which is occurring more than n by 4 times. So we will compare the length with n by 4 for each element. Okay, so we found out these three numbers in O1 time because we directly know that these three will be the candidate answer. And to capture the first and the last occurrence, that is going to be log of n. First and last occurrence of all three number 6 into log of n, which is log of n. So the time is going to be log of n and the space is going to be 1. So ultimately the time is log of n in this case and the space is O of 1, which is better than the O of n. Okay, so let's have a look in the code for both of these approach, like going iteratively or finding the occurrence using binary search. First solve it linearly, capture the length of this array, array dot length count is equal to 1 for the first element, and temp is that element, like we can say array of 0. Okay, so array dot length is going from 1 to 10 power 4, so there will definitely be one element. So we have found out that one element we have captured the frequency to count. So let's handle the corner case where we have only one element. In that case, we are going to return this element 100% of the time this element is present. For I equal to 1, I less than n, I plus plus. If array of I equal to array of I minus 1. In this case, we are going to increment our count. Okay. Else the current element is not equal to previous element. In this case, we are updating our count to 1 and temp element to array of I. So this is the element occurring one time. So Apart from that, we will also check whether at any moment our count into 4 is greater than n. It means count is more than 25%. In that case, we are going to return temp. If there is no answer, return -1. Okay, let's try to submit it. It will be submitted successfully. Okay, now let's check for the approach where we used the binary search to find the first and last occurrence of the element. Our length is going to be array dot length. Okay, so we decided that we have 3 candidates to our answer. Let's capture those candidates. Candidates is equal to, the first candidate is at n by 4, second one is at n by 2, third one is at 3 into n by 4. Okay, so now we will check for all the 3 candidates. For int candidates, we will capture the leftmost index for that candidate. So let's call it first occurrence of candidate in ARR in this array. Int right equal to last occurrence of candidate in this array. Now how do we check the length? If left minus right plus 1, or just multiply it with 4. Into 4. If that length segment is more than 25%, so it would be more than n. It means we can directly return the candidate. Else -1. So now we have to implement these 2 functions. The first occurrence of a candidate in ARR, the last occurrence of candidate in the array. So for finding the first and the last occurrence, we are going to use binary search. So private int first int a, private int then last int integer array and the element. Okay, so we are going to implement the binary search algorithm. Int left is equal to 0, right is equal to array dot length -1. Let's capture the resultant index in the result, which is -1 in the starting. So what is the binary search logic? While left is not equal to, while left is less than equal to right, we are going to capture mid, which is left plus right minus left divided by 2. Okay, if array of mid is greater than a, if the middle element is greater than a, it means a is at the left side. So we will update right to mid -1. Else if array of mid is less than a, if array of mid is less than a, we have to update the left pointer, left to mid plus 1. Else it means array of mid is equal to a. In that case, we will capture the mid in this and we will see whether there is any more element on the left side or not. So we'll update right to the mid -1. Okay, so at this point we have found the value and you will further check whether there is any more element in the left or not. Okay, and after this loop ends, we can just directly return the result. So this is going to capture our our first element. Okay, so we are going to do the same thing with to capture the last element. Int left is equal to 0, right is equal to array dot length -1, and int result equal to -1. So while left less than equal to right, we will capture mid, left plus right minus left divided by 2. Okay, we have our left element with us. Now if array of mid is greater than a, if array of mid is greater than a, it means we have to update the right pointer, right equal to mid -1. Else if array of mid is less than a, in that case update the left pointer, left equal to mid +1. Else when both are equal, just capture our result which is mid and try searching on the right side, left equal to mid +1, and in the end just return result. Okay, so this is mostly the same. In just one difference is there, like for occurring the first element, just capture the current element and try searching on the left side. To search on the left side we have to update the right pointer, and to search over the right side we have to update the left pointer. And in our main function, like with this find spatial integer, we'll just capture the length of this segment for each candidate. If any segment is more than the quarter, then we're going to return the candidate. Okay, let's try to submit our sample test cases. We are getting -1. Okay, so what's wrong here? Okay, yeah, instead of writing left minus right, we have to write right minus left, because right is bigger than left. Okay, right minus left plus 1 into 4 is greater than 4. We are going to return candidate. Candidate are our, okay, these candidates should also be our elements at this position, not the indices. Array of this array at this position. Okay, let's try to run again. Okay, it is passed our sample test cases, submitting the problem. It got submitted and beats 100% of Java users. Okay, so in this approach we are using binary search logic to capture the first and last occurrence for each 3 candidate answers. In this way we are taking log of n time as compared to the previous approach. Okay, hope you understood the problem. Thank you guys.